Now, this question asks you to make a deep copy of a connected, undirected graph, so where each node has a value and a list of neighbors. Now, the standard approach is a DFS with a hash map that will map original nodes to their clones. And the map both prevents infinite loops on cycles, and then it will let you wire up neighbor references correctly as well. So essentially, how the code works is that we visit a node for the first time, we create its clone, and then we store it in the map before recursing into neighbors. And this is a very key step. Now, if a neighbor later points back to a node we have already started cloning, so like a cycle, the map returns the existing clone instead of just recursing forever. So to explain the code, we are handling this edge case over here, which is if the where the graph is empty, which means we are given none, there is nothing to clone, so we just return none immediately. Now, this is the dictionary that I spoke about. The keys are the original nodes, and its values are the copies which we have made of them. So it will serve two purposes. Firstly, it will remember which nodes we have already cloned, so we never clone the same node twice. And then secondly, it will look up the copy of any node when we need to connect the neighbors. This is our recursive function. So the inner function, and its job is given, it's given an original node which is cur, and now this is the base case. So every recursive function needs a base case, like when to stop. So the base case is that if we have already cloned this node, we just return the existing cycle, and this is what's stopping that infinite recursion. Then we have copy equals to node, we pass cur's value. So if we haven't seen this node before, we create a brand new node with the same value, and then its neighbors list dots empty. And this one is important because we are registering before recursing. Now we record the clone in the map before we process the neighbors. And the reason why we are doing this is, imagine if you have a node 1 which is connected to node 2, which is then connected to node 1. So it's like a cycle. I don't have a picture, but it's a cycle. So imagine node 1 connected to node 2, which is connected to node 1 itself. So we start cloning node 1, then we recurse into node 2, and then node 2's neighbor list includes node 1 again. So because we have already registered node 1's clone in the map, that recursive hits the base case over here on top, and it will just return the existing clone, which is half finished, instead of creating a duplicate. So if this line, this particular line, came after the loop, the code would just recurse infinitely. And then in this case over here, we are rebuilding the connection. So for every neighbor of the original node, we call DFS of neighbor, and which returns the neighbor's clone, and we append it to our copies neighbor list. So we are appending the clones and never the originals. So the new graph must not touch the old one. And then at the end, when the clone is fully built, we are going to return the copy, and then we call the DFS function on the node.